Hi, visionaries. Welcome. Behold these images: supercooled liquid crystals, intricate chips, visualizations of particles behaving in ways that defy logic. And then imagine the impact: new life-saving drugs, materials with incredible properties, an understanding of the universe that goes beyond our wildest dreams. We are on the verge of a technological revolution, a revolution that is not a simple improvement, but a quantum leap in the literal and figurative sense of the word. Today, we will explore the fusion of two unstoppable forces: artificial intelligence and quantum computing. This is future artificial intelligence, and I have closely followed the advances in both fields. Believe me, this is not science fiction. It's the cutting edge of research. And what's at stake is, quite simply, the future of humanity. What happens when you combine the learning and adaptation capabilities of AI with the unimaginable processing power of quantum computers? What problems, hitherto impossible to solve, will suddenly become accessible? What new horizons will open up before us? Stay until the end to discover how quantum AI, the union of these two technologies, could transform our reality in ways we can barely conceive of. And don't forget to subscribe for more content on the technologies that are, quite literally, building our future. But before we dive into this fusion, we need to understand the ingredients. First, let's talk about quantum computing. Forget about the computers you have at home or at work. Those machines, however powerful they may be, operate on a fundamental principle. Information is represented as bits, which are like light switches, on or off, 0 or 1. Quantum computing breaks with this scheme. Instead of bits, it uses qubits. Imagine a coin spinning in the air. Before it lands, it's neither heads nor tails, but a superposition of both possibilities. That's the essence of quantum superposition. A qubit can be 0, 1, or any combination of 0 and 1 at the same time. But there's more. Qubits can be entangled. Imagine two of those spinning coins, but magically connected. No matter how far apart they are, if one lands on heads, the other instantly lands on heads as well. And if one lands on tails, the other instantly lands on tails. This phenomenon, which Einstein himself called spooky action at a distance, is quantum entanglement. And what does all this mean? It means speed. It means power. Thanks to superposition and entanglement, quantum computers can perform calculations that would be absolutely impossible for any classical computer, however powerful. They can explore millions of possibilities simultaneously. They can solve problems that we consider intractable today. There are different types of quantum computers: superconducting, trapped ion, photonic, each with its own advantages and disadvantages. And let's be clear, quantum computing is not a mature technology. It's in its early stages, but the advances are astonishing. Companies like Google, IBM, Microsoft, and countries like China and the United States are investing billions in this race. Now, a brief reminder about artificial intelligence. Simply put, AI refers to computer systems that can perform tasks that normally require human intelligence: learning, reasoning, pattern recognition, decision-making. We already see it in action in speech recognition, computer vision, machine translation, self-driving cars. But current AI, however impressive it may be, has limits. It struggles to generalize, to understand context, to reason flexibly. And this is where quantum AI comes into play. The union of these two titans. Quantum AI, in essence, is the application of quantum algorithms to artificial intelligence problems. And why is this fusion so explosive? Because quantum computing can supercharge AI. First, it can accelerate machine learning dramatically. Quantum algorithms can process massive and complex datasets that would overwhelm any traditional AI system. This means training much more powerful AI models much faster. Second, quantum AI can solve optimization problems that are, quite simply, impossible for classical AI. Imagine finding the optimal route for a fleet of thousands of delivery trucks, considering millions of variables, or designing a molecule with exact properties for a new drug, or creating the perfect investment portfolio balancing risk and return. These are optimization problems that quantum AI could tackle. Third, and perhaps most excitingly, quantum AI could bring us closer to the creation of artificial general intelligence, AGI, an AI with human-like cognitive abilities capable of learning and reasoning across a wide range of domains. There are key quantum algorithms that are driving this revolution: quantum machine learning, quantum support, vector machines, quantum principal component analysis, quantum generative adversarial networks. We won't go into mathematical details, but suffice it to say that these algorithms leverage the unique properties of quantum mechanics to perform AI tasks much more efficiently and powerfully. Specialized hardware is even being developed with this new technology. The potential applications of quantum AI are, quite simply, mind-boggling. In healthcare, it could revolutionize drug discovery. Imagine simulating the interaction of billions of molecules at the quantum level to quickly identify the most promising drug candidates, or designing personalized treatments for each patient based on their individual genome, or improving the accuracy of disease diagnosis, analyzing medical images with unprecedented precision. In finance, quantum AI could optimize investment portfolios in ways that are now unimaginable, detecting fraud patterns with astonishing effectiveness, or developing market models that anticipate fluctuations with much greater accuracy. In materials science, it could allow us to design new materials with custom properties, room temperature superconductors, ultralight and ultra-strong materials, new types of batteries. The possibilities are endless. In logistics and transportation, it could optimize the routes of millions of vehicles, drastically reducing fuel consumption and carbon emissions. It could improve traffic management in real time, preventing traffic jams and accidents. In cybersecurity, quantum cryptography could make communications absolutely secure, impervious to any hacking, and quantum AI could detect intrusions and cyber attacks with unprecedented speed and accuracy. And, of course, there's artificial general intelligence. Quantum AI is not a guarantee that we will create an AGI, but many experts believe it is a crucial step in that direction. We could continue listing applications in fundamental research in physics and chemistry, in space exploration, in combating climate change. Quantum AI has the potential to transform all aspects of our society. But let's be realistic. Quantum AI is not a magic wand. There are still enormous challenges to overcome. Building quantum computers is extremely difficult. Qubits are incredibly fragile and susceptible to errors. Maintaining them in a coherent quantum state requires temperatures close to absolute zero and extreme isolation from any external disturbance. Developing effective quantum algorithms is another monumental challenge. We need new ways of thinking, new ways of programming, that leverage the peculiarities of quantum mechanics, and quantum error correction is a crucial problem. We need to find ways to detect and correct the errors that inevitably occur in quantum calculations. We also need a large number of professionals, specialists in the field, to be able to sustain this development. And, of course, there are the ethical challenges. How will quantum AI affect employment? What if it is used to create autonomous weapons? How can we ensure that this technology is used for the good of humanity and not for its destruction? The future of quantum AI is bright, but uncertain. We don't know exactly when we will see practical applications on a large scale. Some experts talk about 5 to 10 years, others about decades. But what we do know is that research is advancing at a dizzying pace. Companies like Google, IBM, and Microsoft are competing for quantum supremacy, the point at which a quantum computer can perform a task that no classical computer can perform in a reasonable amount of time. And while quantum supremacy doesn't mean that quantum AI is just around the corner, it is an important milestone along the way. The long-term impact of quantum AI is difficult to predict, but one thing is clear. If we manage to overcome the technical and ethical challenges, this technology has the potential to transform our reality in ways we can barely imagine. Quantum AI is an emerging technology, but with immense potential. We are, quite literally, on the cusp of a new era. an era in which computing power and artificial intelligence will merge in unimaginable ways, opening up a range of possibilities that we can only dream of now. Share this video to spread awareness of this coming revolution. Leave your comments. What do you find most exciting about quantum AI? What worries you? And subscribe for more content on the technologies that are changing the world. The future is quantum, and it's closer than you think. Thanks for joining us.